Hi, my name's Relevant, and I can't believe I found the schematics for this old wireless speaker thing I got here. I might actually be able to fix the thing. As you can see, it's already gutted because I've been exploring it already. I must have had this thing for about 20 years now. My mom won it in one of those charity lotteries she always signed up for. You know, there's always this consolidation prize, crap. Sometimes you get, sometimes it's useless. This thing was actually useful to me. I used it on my TV actually for a while as a subwoofer because it had a little bit of, added some bass response to the built-in speakers. And of course, you drag it out to the occasional bush party and you're a bit of a hero. There was that awkward time in the mid 2000s, after boom boxes. Nobody had them anymore to bring them out to a party, but before the Bluetooth, little portable Bluetooth speakers really took off. This was kind of in that awkward era. It wasn't Bluetooth. It had a bass with an aerial on it. There was an aux in. You could plug your MP3 player onto it, then it would broadcast wirelessly to this thing. So it has a bit of a radio receiver built onto it. Now this thing, I found it in a junk box and I'm like, oh hey, I wonder if I can scrap some components off that. Maybe an op amp or some JFETs. So I took it apart and sure enough, yeah, there's an op amp on it. Let me get this circuit board out actually. In order to do that, I have to disconnect the aerial, which is glued onto the inside of the box. Come on. Ugh. Get the solder wet and then it's just like, nope. Come on, go through the hole. Ugh. I need a couple more hands to do this apparently. All right, here's the circuit. Very rudimentary. This thing is branded Finer Things. Oh, posh. And I just dropped screws on the floor. But the board itself says Rostec. And there actually is a part number. RS950 revision 0. But sure enough, it has a 4558 op amp on it, so yeah, I could scrap it for parts. No JFETs though. I'm looking for some audio JFETs. There's just some generic transistors on here, and then a couple other ICs. This SA2111C, this thing, which is completely unlabeled, and then this guy right here, which you cannot see the label, but I know what it is. So here I am thinking, I can get an op amp out of the deal. I'm not really one to scrap capacitors and stuff unless I have a value that I really need. Oh boy, Cheng X. Oh, that sounds like quality. On the bottom, there's actually a 6-volt regulator. Oh, great. Maybe a regulator's blown, right? I'm tearing into this thing and I completely forgot to tell you, it's broken. Yes, one day the subwoofer just decided to up and stop working. Not very useful, just a little squeaky tweeter, right? But anyway, I decided just for kicks to punch in Rostec schematics. I didn't even put in the part number. And sure enough, I found this and I can't believe it. It is the schematic for this thing. Everything matches. The component values with their component designators match what I'm seeing on this schematic. So we see over here the SA2111 and the transistors, that's part of the radio receiver on it. So I don't know if the radio receiver still works. I might have lost the base station. It doesn't matter. This thing has an aux in on it. That's all I really care about. So we can eliminate that. This voltage regulator just seems to power these LEDs in the radio receiver. So that doesn't matter. The unidentified guy right here is this dual op amp dealie. It's the power amp for the tweeter. The tweeter works, so we can eliminate that. That narrows us down to the 4558 here and the what's called a BA5417. That's going to be the big guy here, and the BA5417 is the power amp for the subwoofer. Based on this pinout, it's working as kind of a push-pull configuration. It's a bridged amp. And then the 4558 over here, well, I'm not going to run all through the signal here, but the main signal comes in through here. There's a switch integrated into there that disconnects the radio receiver, comes over here, there's the volume pot, splits here, goes down to the tweeter section, goes this way into the 4558. The 4558 appears to be some sort of preamp. Now, I don't completely understand what's going on here, but I'd hazard to guess we have some sort of low-pass filter because it's a two-way speaker system. So at some point in the circuit, there's going to be a low-pass filter. I believe this is it here. So we have a bit of an active crossover. And then it sends it down over to here, and then that blasts it out. So that's great. Stuff is so much easier with a schematic. Usually, this is unheard of. You don't find schematics online for cheap, random, oddball, unidentified consumer electronics like this. This is the kind of stuff that once it's done, it's done. You chuck it out and start again. Now here's the bottom of it, and I'm gonna try to hook this thing up and run some tests. Kind of mapped it out here. Woofer connects here. The LEDs, well, that's not exactly important. This red line connects there, then green white, green black from power board goes here. The rest of this connects to the top, which I guess we need in order to turn the thing on, right? Testing this is gonna be tricky. Or will it? Oh. This has layers like an onion. Why'd they glue this in like that? Seems unnecessary. Okay, not too worried about the tweeter, even though it would be convenient. I hope I remember where all these screws go. I'm just kind of tearing into this thing. Oh, look at the little cutie. Okay, the tweeter, red, white, here, and the rest of this crap, black, white. Must be black, blue, black, yellow, white, white, and oh, green, white goes directly to the power board. Must be the switch. All right, this thing should work now, or at least as well as it can work. Mostly disconnected. Let's find it some power. It apparently runs off 12 volts, which might have been rarer then, but it's easy to find now. Oh, it lit up. Blang, blang. Ah, radio static. You know what? We can use that static to our advantage because it's going to be putting out a signal that we can try to probe on here. I'm getting a little, oh. I want to get to the bottom of this thing. Not connected. Okay, our perspective here matches our perspective here. Now I'm just gonna do some basic power probing here to see if this chip's getting power. We can turn the volume down for that. That's gonna wear thin, isn't it? All right, VCC is pin 4. Gotta find a source of negative here. These two strips at the end here are ground. Let's grab onto one of them and try this again. Oh, careful. Now there's also standby. So you see on the circuit here, power comes in from here, and then it connects directly to the chip itself. And then this switch actually triggers a standby circuit on pin 8, which apparently is this guy right here. Okay, it is getting power, 7.8 volts, but that makes sense. There's a 22K dropping resistor here. You don't necessarily need full power. You just need to tell the thing to turn on. So where's the input? In1 is on ground because it's the phase inversion. In2 is right here, 4th from the end. So if we tap, nothing. Let's give it a little bit of a path here. Let's give it a little bit of the VCC. Okay, we're not gonna get impedance through our meter to do that. So let's arbitrarily grab any old resistor capacitor kind of thing. Well, like the forced capacitor in reach, just a chintzy little guy like this. We'll grab some voltage from somewhere. We know that is part of a voltage circuit and nothing, bud. We know there's power, so if I, bridge this capacitor over to that input pin and that chip was still good, it would be like jumping there, bud. Jumping. And that's my suspicion. My suspicion is that this BA5417 is fried. Unless there's just some other reason. Where's R2? 22K. Looks like it should be right about here. Yes. What's on either side of this R2? That's the only thing I can think of. It's not using the standby signal to turn on. So we know it's right here. And this is probably a ground. No, that's the power. That must be a ground, yes. We've just bridged that R2. She ain't doing nothing. Let's turn up the volume here. Get some of that white noise. Yeah, I think this is safe to say, because you look at this circuit, and other than those IC op amps, the circuit's completely passive. It's all just resistors and capacitors. There's nothing else that could fail on this board, really, other than solder joints, but that's not the case. We're shocking on that op amp and it's doing nothing. So this pupper right here must be donezo. Now, why would that blow to begin with? I don't remember it having any good reason. Now, fortunately for me, I'm going to be putting in a DigiKey order soon. DigiKey has them for $4.30, 47 in stock. I think I'm gonna be ordering another one of those and putting it in here. So let's do a little bit of movie magic. Little bit of. Oh, how cheesy can we make this? Okay, how about one of these? How about one? Are you ready? Oh, there we go, bud. How's that a focus? A fresh shiny new BA 5417. Hopefully that solves our problems. Let's install it. You know, sometimes those are date codes. 9 of 09, 2009. You know, I guess, I'm not sure if this guy was 2009, but oh, you're a frigger. How are we supposed to get that out? I guess we're uninstalling this with the heatsink attached, but at least it can unbolt from the bottom here. All right, so we gotta get these solder joints undone. And that is gonna be tricky with it still attached to the heatsink because I was thinking I was gonna just end up cutting this off. We'll see if I could get all out in one fell swoop. I doubt it though. We'll see though. Sometimes it's just a case of getting all the flux on there. You know, this is really handy for small stuff. I am not sure how handy as flux has been for larger items like this. All right, let's see what we can do here. Yeah, no, this isn't really working. Okay, plan B. Can we snoot in here at an angle? And sometimes, if we get a small slot screwdriver, we can kind of do one of these. Funny, it's loose, but... clamp it down and kind of... I said clamp it down. That's not working at all. Let's try, I don't think these pliers are going to have enough resolution to grab onto that thing. Oh, yeah, okay, it's turning. Okay, we've cracked it loose. Can we, there we go. Okay, it's off. And well, now the old one, we just kind of, not like that. That's not gonna work. First we'll clean up on this a little bit so as to not gum up our cutting tools. Wonder what the chances this heatsink goo is somewhat conductive in it, because it's like on the contacts there. Maybe that's what blew it. While we're at it, we'll clean up on the heatsink too. It's going to get fresh heatsink goo. This is just the cheapest stuff anyway. Alright, yes, I think a little bit of negotiations are about this, eh? Yes, quite. I cut a bit too deep and nipped this capacitor here. I wonder how much of a problem that will be in practice. I don't know that I've severed it. 100 UF 16 volts. Oh, of course it has to be a value I don't have in stock. I don't think it actually corrupted the capacitor though. What is that? C7. It's on BS1. Well, if that capacitor's BS, then what's the point? Standby pin control voltage 3.5 volts. I think I tested higher than that. Maybe we need to bring that down. So BS1 is, apparently that pin is just BS. That's small for a 100U16, if you ask me. Let me check to see if I can find one. 100U16 ELNA. Where did I even get this guy? 100U16 ELNA. See how much bigger it is? Maybe this has bad capacitors. Unfortunately, I do not see this fitting and clearing that position. Okay, well here's what I'm thinking. Just to be on the safe side, right here is an identical 100U16. We're gonna go to where I damaged that capacitor because it's a tight fit. We're gonna remove this one, put in this identical one. Okay, that's good now. Oh, this computer motherboard's got some little 100U16s on it that don't look like they're completely worn out. All right, we'll take this salvaged 100U16. I'm gonna put it here where I got a little bit more room. Well, that thing's cute. Well, let's tack that on there. 105C rated, this is a better quality capacitor. All right, back on track. We need to get all these dead contacts out of these holes, which should be relatively simple now that the IC's gone. Ooh, I might have a ripped trace off the board. How did that happen? Right there. That's a ground pin. Okay. It's all surrounded by ground planes, so I'll be able to work around that. But yeah, we gotta forget, this is a cheap Chinese PCB here. It might not have the strongest traces in the world. Oh yes. You can just pull these pins out from the other side. Oh, that was relatively easy. Now we just have to suck out those holes without damaging the contacts. Some of the PCB bads almost didn't make it. PCB bads? Bads, yeah. The PCP bads. Sure, bud. You give her a go. Let's see, is our new chip gonna fit on there now, bud? We just slot in like that. Oh yeah, it's gonna go in just fine. Oh, there's an example I'm talking about. Can you see where those PCB pads peeled up? That's gonna be problematic. We need to hope that we don't blow this one. We're gonna have to check some of our specifications. R2 22K is subject to controversy because I question, why did this blow in the first place? Based on what I'm reading online, there's not much that can go wrong with it. Like, it's just, it goes in, it goes out. Power's fed directly to it. The way these op amps work, they don't really need biasing in that regard, but they may need biasing somewhere else. R2 22K, maybe that value needs to be increased to better regulate what's hitting it. R2 22K right there. Found you. Let's check the impedance on this thing, see if it's drifted. So tiny you probably can't see it. Can't even grip onto it. 21.9, close enough. I'm gonna leave it omitted for the moment, because if we're getting excessive whatever on that position, I don't wanna blow it the second I fire it up. In the meantime, in order to get this thing mounted, I do believe I'm gonna have to get it back on the heatsink here. I'll tail a fresh application of heatsink goo, probably lots. I don't expect that this thing's actually putting out a lot of heat, though that is a sizable heatsink. It's nothing to scoff at. Maybe this heatsink's not big enough, though I don't recall running this loud when it died. I just remember it arbitrarily just not turning on one day. I kinda need to get this faceted on as straight and true as possible. Maybe I shouldn't be doing this with a turbo driver, because as you torque it up, it wants to twist out on you. You need it to be flat. Okay, I think I got it no. Not good enough! However, while it's mounted, maybe if I just do a little tappy tap tap, like this. Yeah, that did it. Just nudge it over. Just nudge it over. All right, I gotta get it slotted back in here. Carefully as to not bypass any of the contact pads. Okay, yeah, that looks good. Looks good, sir. Now if we bolt it on, it won't go anywhere. It'll be easy to work on. There we go. There we go. I pretty much just hammer fresh solder on here. Just gonna go through and look to see if I can find any sketch looking solder joints. Maybe I should just give this thing a complete DROS. Alright, so what I'm gonna do, I'm gonna temporarily replace that standby resistor with just a couple leads that I can grip onto. So that's the only hunch I have as to why this thing died. Too much standby circuit fried. I'm gonna try a couple different resistor values there to try to stay consistent with the specifications on the data sheet. It's funny, there's a fuse here, but there's no fuse there. Wonder if it's dirty power. Pretty sure this AC adapter I'm using here is higher quality than the original one. Where's my little cheat sheet? I have a map of all the connections here. Okay, we're all hooked up here. Just need some test leads. I'm gonna double the load on that standby circuit from a 22K to a 47. All right, so 47K on standby circuit. Yes, sir. Gotta make sure none of that shorts out against each other. And then I kind of need to get this so I can test on it like that. All right, plug it in and see if it's gonna work now. Oh, I saw smoke. What the frick was that smoke, bud? I heard the woofer. Oh, really? Oh, that woofer's popping at least. Did I actually see smoke? Like, I analyzed the bottom on the board. I can't see anything wrong with it. Everything sounds like it's working. Like, I'm getting hiss out of the tweeter, getting hiss out of the woofer. I want to check my standby voltages, which is going to be tricky to show you exactly. Need to grab ground, like right around here. And then I need to probe pin 8, or just whatever side of whatever side of the resistor here. So on one side, 6.8 volts. On the other side, 11.9. 6.8, 11.9. All right, where's my calculator? No, seriously, where's my calculator? No, seriously, where's my calculator? It was right in front of me. What is wrong with my brain? 11.98. Take away 6.81 is a 5.17 volt drop. Divide that by 47,000. That's 0.00011 milliamps dissipation. Standby current can be as high as 150 milliamps. Okay, so that's not a problem then. 3.5 volts up to VCC. I guess that value's not that important. Okay, well, let's test on it. Now my assuming is once I plug an aux into this, it'll stop being able to radio receive. Or will it just radio receive worse? Maybe this thing's not good for the modern era. Gotta turn up the volume here. It's cranked right now. Oh, I feel it vibrating. We definitely have bass now. And that thing's friggin' giving her. It's just there's no box, so it doesn't sound like there's any. The tweeter still works even though we saw smoke. It is picking up a lot of interference from that phone, man. Oh boy. Okay, where's our little 22K? There it is. Now if I disconnect this, the sub should turn off. Yeah, indeed it did. Now let's put this other standby resistor in place. Turn back on. Now how hot is this thing getting? It's putting out some heat, yes. It is obnoxious, the interference it's picking up. Oh, wow. Okay, so I guess it works now. Let's put it back together. Yeah, this might not be good for plugging a phone into. I'm thinking it's gonna end up in the shed, hooked up to a shed computer so that I could just hear beeps and boops and stuff like that. Like, you know, I don't take this thing that seriously. It's just nice to have it working. And you know, if I can get it working just putting in a little bit of time in a $5 part, why not? Some stuff, it's like the amount of time it's gonna take and the amount of parts, it's just not worth it. Especially if you're paying someone else to do it. I would assume probably cost a couple $100 to get someone to fix this for me who was qualified to do it. Question is, can I find the wireless base for it? And then maybe it'll actually be kind of useful within its intended purpose. I can't remember if I ever actually plugged a phone into this thing. I'm vaguely trying to recall if we had music on our phones back then. Well, I just gotta go put that resistor back into place. Where'd I put that resistor? Here it is. These are tiny resistors. Like, what are they? Frig all of a watt? Like, with how tiny the components are. Jeez, you could probably break this thing by sneezing on it. All right, that resistor's back in place. It is time for reassembly. Reassembly. Which is a multi-step process. Hopefully I can figure out where all the screws go. So we gotta get the lid on first. All these wires go through here. And this little power board just tacked on there. It was half covered in glue. Not sure why. Pretty sure it's probably just some dinky little screws like this. I don't think anything else went on the top here. Pretty sure this speaker bolted in from the bottom. Stupid thing works by twisting up the wires. Wow. Just screwing this top. Now the tweeter, board specific board goes in something like, how's the board going again? That's where the aerial hooks up. Oh, slanted. And the tweeter connection is up here. So we want the tweeter to orient something like this. Yeah, it just slots into there. You have this crossbar that holds it into place. Also screwed down using the smallest screws we have. There's 4 of these smaller screws. Or actually, no, there's more than that. Uh-oh. Now the board goes into place, but the tricky part of the board is we have the antenna for the AM, or no, the FM, or the whatever. And we gotta solder that on, because it's glued onto the side, right? It's hard lining this up. Well, this is fun. There we go. Right, now let's tack that in. That'll do. Now I flip that around, and the board bolts down onto these 4 posts. So, what screws you figure that uses? Probably the last 4 remaining small screws. Yeah, that sounds about logical. And they're not magnetic. I think they're stainless. Or is it just my screwdriver that's not magnetic? Oh, the screws are definitely magnetic. I think it's just the screwdriver. Huh, that should do. Now connecting wires. Well, that's all these connections. Now I actually have some structural integrity issues here. I'm gonna maybe do a little something about that before we put it together. Also, this thing has these clips that don't make any sense, right? So these are the mounting points for the base. And I don't get what effect they were going for here because these things just slip off. Like literally, they just wedge on there. And it's kind of like, okay, what, is there something that like once it tenses up, it kind of flexes them and holds them from going away? Waiting for the glue gun to heat up so I can fix on that. Come on, I want glue. Oh, okay, I think we got enough to make this work now. Gonna, you know, reinforce these mounting points. There's a few that I've already glued up because, well, the bottom fell out of this thing once already. Where's that crack? There it is. We glue up this crack? Maybe. Use a little bit of the Canadian Handyman secret weapon hockey tape. Put a band of this across the bottom here. Oh, okay, that'll kind of help keep it together. And then I'm just gonna go ahead and, oh, it keeps it together good enough I can barely see the line. I'll just run a bead down that crack. Yeah, I think that should help the situation. All right, so getting the bottom attached is kind of a multi-step. This whole thing goes together, it comes apart funny. I think you know it, bud. Because like this thing's kind of stuck to the battery box. individual red goes here. No, looking at it upside down now. The individual red goes here. Woofer. Oh, that attaches the other side. You gotta get this guy close in here. It's gonna start falling apart. Okay, this is tricky now. And the woofer. And this green black goes to the power board. All right, it's all plugged in now. Gotta kinda, is there any specific orientation? Oh, there is, because the jack's here and it's labeled. Ah, yeah, here's a little notch. Now, you have to take the battery box off to get at the screws on the base. 1, 2, 3, 4, 5, 6 screws. Let's find 6 screws that are the same here. Pretty much all the remaining screws are the same, except for some ultra long ones. Except, you know, we need a few more hands. Now, how does this go together again? First off, it needs a vacuum. It's dusty as frig. Guess all the sub-poofting against that just kind of causes it to accumulate. It slots on like that. Now you got to get inside the battery box. We have 4 long screws that bolt this assembly, this sandwich together. And then the battery box goes on. Something like this. There's a notch. Got to find that. Oh, there's the notch. Now you need a skinny bit to get deep into these holes. Ho, ho, ho. I'm short 1 screw. Well, that's no frickin' good, bud. Where's that last screw? Oh, there it is. It was just hiding. All right, then we have plugs that go into these holes that double as feet. This takes like 8 Cs. I'm gonna modify this thing to run on rechargeable lithium ions if I actually use the thing. Brush the scrap bits of solder off of it. All right, bud. It should be good to go now. Trying to receive radio signals. Let's plug this aux in back in it. I think we might need a longer aux cable. And it's sounding awfully dark. Oh. It's cranked. Give it more signal from the like it's not particularly loud, but it has a surprising amount of hump. I guess it works again. Maybe some electromagnetic shielding? Like maybe if I wrap this in foil and then ground it out? I don't know, man. Maybe I should find the base for this. Or not the base, the transmitter. Or maybe a longer aux cable, I don't know. Or maybe not using it with a phone. Oh. Or maybe what I need to do is find a Bluetooth receiver and install it in here. But then if it's this noisy just with a phone nearby, I can't imagine how noisy it would be with Bluetooth. But hey, I can't believe I fixed this thing. It's been sitting in my junk pile for years and now it's possibly useful again. I always thought it kind of looked cool. Kind of monolithic there. Carry handle. Ba-ba-da-ba-da. Again, I'll probably just use it for sound in the shed or something like that. I don't know. I don't know. Either way, I hope you enjoyed this. Sometimes I fix things. Though I'm not that good with solid state, so sometimes I try to fix things but don't fix things. But if you like this, well, hey, stay tuned. There's bound to be more. I think you know it. Is this thing even going to be useful? Like, frick. Oh well. I guess we'll find out.